All right, so in section 4.2, we are using shortcuts now to show triangles are congruent, because yesterday we had to find 6 pieces of information. Well, now today we only need 3 pieces of information. And so our first, this is actually a postulate, our first postulate states that if we know the 3 sides of one triangle are congruent to the 3 sides of a second triangle, then those 2 triangles have to be congruent. And I just showed you a demonstration of that actually working out. Okay? Anybody questioning that? Anybody having issues with that? The nice thing is once we know those triangles are congruent, we then also know all the other information about those triangles. Meaning, I have side, side, side congruence going on here. Therefore, I also know that these angles must be congruent, these angles must be congruent, and these angles must be congruent. Okay, once I've shown the triangles are congruent, then I know all the information about the triangles. Okay? Well, let's then use this in a proof. Now, the proofs we're going to do today, I want you guys to understand that we're going to be doing flow proofs for triangles. Okay? We've only did one example of a flow proof so far in this class. And so off to the side here, I'll show you quickly. It is on the board, but I want to show people here on the video that anytime we are doing a showing triangles are congruent, I'd say 98% of the time that we show triangles are congruent, we're going to be using a shortcut. First off, side, side, side is the only shortcut we have so far. Okay? We will have more. But what we're going to do then is we're going to say, okay, these 2 line segments are congruent. These 2 line segments are congruent. These 2 line segments are congruent. That then tells us that these 2 triangles are congruent. And remember, the flow proof looks like this, where the arrows show you the movement of the logic, right? Okay, so that's what we're going to have. We're going to be putting in congruent sides, congruent sides, congruent sides, therefore telling us we have congruent triangles. Something else to remember about flow proofs is that the statement goes inside the box. The reason for that statement gets written below the box. Okay? This structure we're always going to have. Like I said, 98% of the time, if we're trying to show triangles are congruent, you're going to have this structure. This exact same structure. 3 things going into one box. Okay? Now, there will be times in this class where you're going to have other things out here. You know, maybe this statement which gives us that statement. Or maybe two statements that give us that statement. Okay? You might have other things working in this proof, but that basic structure will be there. Okay, again, at other times in this class, you might see where, okay, we have that basic structure, but then we're trying to show something else. The fact we have congruent triangles tells us something else. Okay? But again, that basic structure will be there. All right, so this is what we're doing for a flow proof. Not flow proof. Flow proof. All right, questions on a flow proof? Structure, how we set them up? Then let's write one. Coming back over here. We're given that line segment LM is congruent to line segment NP. We're also given that line segment LP is congruent to line segment MN. I told you that we're going to have that basic structure. So I'm going to start this by drawing that basic structure. So there are a couple of nice things about doing flow proofs like this. First off is now that I know I have that structure because I'm trying to show that triangles are congruent, I can get more points on a test or a quiz by simply filling in my last statement. I know my last statement is going to be that triangle LMN is congruent to triangle NPL. Okay? And because they told me that I'm supposed to be using side, 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 I can get an extra point by saying, hey, that's going to be by side, side, side. You can't do that with a two-column proof. Okay? You can't do that with a two-column proof. You can't just fill in the final statements and reasons. Okay? But we can with a flow proof. All right, well, like any proof, we got to fill in our givens. Now, we are given congruent side lengths, right? We're given that these two sides are congruent. We're given that these two sides are congruent. Those are sides of our triangle, so those need to go in two of those blanks we have. Line segment LM is congruent to line segment NP, and that was given. Line segment LP is congruent to line segment NM. And again, that was given. Nice thing about flow proofs is that we now see, hey, we need one more piece of information, and then we're done. We need one more piece of information. And this one more piece of information happens to be another side. How do I know I need another side? Well, because they told me to use side, side, side. Right? So looking at the diagram, we know line segment LN is what we're going to be working with. And why? What's my statement? It's just LN? I can't just say LN. LN what?
LN congruent to LN.
Line segment LN is congruent to line segment LN. And why is that? How do I know that's true?
It's reflective.
Careful, it's not reflective. Sounds like that though. Reflexive. The reflexive property of congruence. There we go. That is our proof that we have congruent triangles. Questions there? Personally, I really like flow proofs. I think they simplify stuff for us. Flow proofs are not always the easiest way to go about a proof, okay? But when proving triangles are congruent, I think they are. Okay? Any questions? No? All right, then let's try the one right next to it. I want you guys to do this on your own. But remember, we're all going to start with that basic structure. We're all going to start with that basic structure. So please finish this proof. All right, I'm hoping that everybody noticed that this is essentially the exact same proof we just did, right? We are given that line segment BC is congruent to line segment BF, that's marked in the diagram. We are given that line segment CD is congruent to line segment FD. Again, that's marked in the diagram. And one more piece of information we could find dealing with sides is that they share a side. Line segment BD is congruent to line segment BD. And why is that? The reflexive property of congruence. And please, yes, tell me it's the property of congruence, because remember, there was a reflexive property of equality. We're not using that one here. So we now have 3 sets of congruent sides. So that means our 2 triangles, triangle BCD, will be congruent to triangle BFD. And that is by side, side, side. On the back side of your notes, there's a little bit of vocab we need to talk about. Okay? We need to know what it means to be an included angle or an included side. Okay? So the included angle or the included side. So if we're talking about the angle, if we talk about two side lengths, or two sides of a triangle, the angle between them is then the included angle. All right, so the included angle is the angle between two sides. Similarly, with the included segment or the included side, if we're talking about two angles, change the color there. If we're talking about two angles, the side between those two angles is then the included side. All right? Make sense there? So an included angle is between two sides that we're talking about, and an included side is then between two angles that we're talking about. Okay? That will come into play more over the next couple of days. But it definitely comes into play in our next shortcut, which is called side angle side. Side angle side. So side angle side says that if two sides and the included angle, again we just defined what does it mean by included angle. So if two sides and the included angle of one triangle are congruent to two sides and the included angle in a second triangle, then the two triangles are congruent. Okay? This works the exact same way as side, side, side. It's just a shortcut, but rather than needing three congruent sides, we can now have two congruent sides and a congruent pair of angles between the two sides. Right? So if I was going to do a flow proof, rather than having side, side, and side, I would have sides, a pair of angles, and a side, then showing that my triangles are congruent by side, angle, side. Right? It gets run. It's run the same way. Okay? It's run the same way. So real quick, as just some practice, let's take a look here at the bottom. I want to know, can we show that these two triangles are congruent? And if so, why?
Because they're side angle side.
Yes, and we don't need to say yes at the postulate, but in this particular case, with these shortcuts, all we need to say is side angle side. SAS. Okay? So yes, by side angle side, we have two congruent sides, and the included angle is also congruent. Let's look at the one right below it. Right below it there. Are we able to show these two triangles are congruent?
Yes, side, side, side.
Yes, by side, side, side. Excellent. All right. Set B. Set B, what do you think?
Yes, side angle side.
Careful. We have two sets of congruent sides, I agree. But do we have the angle between them?
No.
No. This is called side angle side because I literally need two sides and the angle between them. Okay? So I have that in the first triangle, but I do not have that in the second triangle. I need to know this angle, not the one they give me. So not enough information. They very well might be congruent, but we can't say that. We don't have enough information. Okay? And our last one right below. Do we have enough information here to say our triangles are congruent? Okay, yes. By what?
Side, side, side.
Or, we actually have options here. We could say, or, we could come in here and say, well, I know that these are vertical angles. Right? Isn't this here a straight line?
Mm-hmm.
And isn't this here a straight line? So I have vertical angles. If I use the vertical angles, I could say side angle side. Okay? So sometimes there's going to be more than one way of showing triangles are congruent. You don't always have to use the side, 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 or always have to use side angle side. There might be multiple ways. Okay? You need to keep your eyes open for other things we've talked about. Parallel lines giving us information, vertical angles giving us information. Okay? All that kind of good stuff. All right, one last example I want to do then. It's actually up here at the top. In order to use side angle side, what other piece, there's one more piece of information we need from this diagram to show those triangles are congruent. Who can name it?
Another side. An angle on another side.
But we only need one more piece of information. So
We need an angle
we need an angle. Why? Why don't we need a side?
because we have to. If you look at the triangles, they're like flipped, the reflexive.
Mm-hmm.
And if we have one, then we'll have another one, but we don't have any angles.
Okay, but which other side do we already know?
The FG and ED.
Nope, we don't know FG and ED. We do not know these two sides.
E,
We know which ones?
EF.
DF. How do we know DF is congruent to DF?
Because
The reflexive property. We already have that information. Okay? What information is not marked in the diagram and that we're not able to just come up with on our own from the diagram?
Angle.
An angle. Which angle specifically?
The E. Angle F.
All right, well, we can't say angle F. We can't say angle F because if I say this angle F is congruent to that angle F, that doesn't give me side angle side. Okay? So we've got to make sure to name angles properly. We can't say angle F. Remember, first off, just point to the angle you need. Hopefully everybody can identify the angle you need because it has to be the included angle, right? We have two sides. Look at that top triangle. We have two sides. We need the included angle, right? If you point to it with your finger, we should all be pointing to this angle, right? Great. What's the name of that angle? EFD, or I heard somebody over here say name it the other way, DFE. We have to use 3 points to name that angle. EFD is what I'll call it. So we have to know that this angle is congruent then to what other angle? And again, in the other triangle, look at the two sides we know. Point to the included angle.
GFG.
We should be pointing to this angle down here. And so again, two ways of naming that. GDF or FDG. Okay? But that is the other angle we need to know. If we're given that extra piece of information, we would then have enough information to show our triangles are congruent by side angle side. Questions?